I still so many people like taking shortcuts. Graphing right now is a shortcut. The questions on your test will not just say what are the x-intercepts. It'll say what step is missing, who solved it right. Um, I don't know, what's the first step in factoring? Like it's not just gonna be the final answer. Today's lesson specifically, and let's actually even look at the study guide, because the study guide was just like your real test. We are assessing you on if you can identify perfect squares. So let's see. Okay, select all expressions that are squares of linear expression. All right, so take a look. My screen only. This is like a test question. Also on your study guide too. We want squares of linear expressions. Is the first one a square of a linear expression? No. No. Do you guys recognize what this first one is? Okay, I can tell you it's not going to be a perfect square. Let me tell you that. Because our perfect square, when they're in standard form, will have 3 terms. And this only has 2 terms, right? So just don't pick that one. We'll talk about what that is in a second. Is this one considered a perfect square? Yeah. What's wrong with it? One has a plus, one has a minus. That makes it not a square of a linear expression because it's not the same thing times itself. So don't take that one. What about this one? Would this be a square of a linear expression? So you have to probably factor it to see. That's probably the easiest way, in my opinion. What 2 numbers multiply to 25 and add to 10? And because it's the same exact number, same exact sign and everything, that is going to be one of the answers. There might be more, there might not be. What about this one? Is this a square of a linear expression? Let's check it by factoring. What's the square root of 16? So it'd have to be 4 times 4. Is there any way that I could manipulate the signs to make it add to a -4? So then it's not that way. This is not a perfect square. Let me even see if there's other numbers that make that work. Because it might be prime. And I can't think of any that make it work. So this one's actually prime. It's not gonna be factorable at all. Anyway, this next one, is it a square of a linear expression? No, because it's a 2-term. We know if they're a perfect square, they create 3 terms. So no, these are perfect squares, but they are not factorable to something that's times itself. Okay. Next one, is that a square of a linear expression? It is. It's literally an expression squared. It's in factor form. It's that times itself. Right? So that one, those 2 would be the only answers. What I was trying to get you to recognize up here for the first one is that it is a difference of squares, but that's not the same thing as a perfect square. Okay? Difference of squares is the ones that, if they are perfect squares, you put the square roots with 1 plus and 1 minus. So this is the factored form of that. Again, they're not exactly the same. One has a plus, one has a minus. So that's why that was not a square of a linear. Good, any questions? Yeah, well, you have a practice to assess you on some of the learning targets from today. So take shortcuts, actually know how to solve it. This one's number 3 on today's practice. And we have to put that into standard form, which means we need to multiply it out. A common mistake, so this is not going to be the answer, but a common mistake would be to just transfer the exponent to both terms and say that it's like 25 plus x squared. It's not. Anything that's like a perfect square should actually give you a trinomial. So anytime there's plus or minus in the parentheses, you can't do that. You have to expand it, which means like if this tells me to multiply this by itself, write it out as this times itself. And then FOIL, double distribute, area model, whatever you like best. I think I'll do the area model. And the way I would set it up is it would be 5 negative x, 5 negative x, and then we're multiplying. What's 5 times 5? 5 times negative x. Over here, 5 times negative x. And negative x times negative x. Positive x squared. Okay, so then at this stage, you would combine any like terms, which I have a like term here and here. Class, so it's negative 5x plus negative 5x. No, negative 10x. So those are my like terms, and maybe you wrote it in this order when you were multiplying or something. You can write it, like you can put it in the correct order, or you could just look like a is always in front of the x squared. So what number is in front of the x squared? So the 1 will go here. What number is in front of the x? Negative 10. That will go here. And yes, we do want to put the minus there because right now I have it as plus. You need to put minus 10. And then the x is already there. You don't need to write it again. And then my single number is 25. Don't put any extra spaces or anything like that. If you were rewriting it in the correct order first, you just need to make sure you keep the sign that's in front of each term. So this is a positive x squared. This is a negative 10x. And this is a positive 25. And that's my ABC. All right, questions on this one? Questions on others?